analyze a real embedded system schematic. This is a USB-C powered ATtiny10 base circuit. Simple, compact and looks correct as the first glance. But it is really corrected? Let's break it down like a professional hardware engineer. If you are designing a PCB or working on an embedded system, this video can literally save your design from failure. Because a small mistake in schematic equals to the dead boards. Let's start with the USB-C section. We have a USB-C 16 pin connectors here. Now since this is a power only design, only a few pins are used. Vivus, ground, CC1 and CC2. You can see a 5.1 kilo ohm resistance is the connected with CC1 and CC2. This is the correct way. This registers tell us that the USB source. Hi, I am a device. Please provide a 5 volts. So far, good designing. Next, move on the power path. Next, Vivus goes through the small fuse and then VCC. This is also a good practice. Always protect your circuit, but here comes the first problem. There is a no proper input filtering. In real hardware, USB power is noisy. You should always add a bulk capacitor 10 microfarad and a small capacitor like 0.1 microfarad. Also, there is a no ESD protection. USB port is highly sensitive to a static charge. Without a TVS diode, your MCU can die instantly. So the section is the functional but not robust. But there is suggestion in the schematic because of we don't use the data positive and negative pins, so we neglect the TVS diodes here. Now let's move on to the brain, that is ATtiny10. Power connection looks fine. There is a decoupling capacitors, but the value is not present. Reset pin has a pull-up resistors also correct. Programming pins are exported using TPI data and TPI clock. That's a good design thinking, but here is a caution. If you are planning reset as a GPIO, you might look yourself out of programming. So always be careful with reset configuration. Next, move on to the LED section. There is an LED connected with the resistance that is 330 kilo ohm. This is a critical mistake. Let's do a quick calculation. At a 5 volt, the current becomes almost zero. That means LED is not glowing, not dim, no flash, no brightness, so completely off. This is a very common beginner mistakes. Correct resistor value should be a 330 ohm. So I change into the 330 ohm. Okay. Or 1 kilo ohm for the normal indication. This is single mistake can you make you think your entire circuit is not working. Now looking at the GPIO and programming lines, everything is directly connected. In real world designing, it is a good practice to add a small series resistor like 100 or 200 ohm. This protection the microcontroller from accidental shorts or spikes. So let's summarize this design. What's good? USB-C implemented is corrected, basic structure is a clean, programming interference is export. What needs improvement? No ESD protection, weak power filtering, incorrect LED register, potential reset pin. So overall this is a good beginner level designing but not production ready. If you are designing PCB, always remember a working schematic is not enough. A reliable schematic is what matters. Because in hardware mistake don't giving warnings, they destroy the components. If you like this kind of real circuit analyze, follow the channel. Next video we will fix the entire design and convert into the professional PCB. See you in the next one.